so O-level live stream, this is our 8th live stream for the year. By the way, those of you who just joined us. Okay, last call. Those of you who have yet to join us. Okay, sorry, I'm blocking the pin. Maybe I should lift this up a bit. Okay, the game pin, guys. Okay, last call. After this, you cannot. After this, if you join, you might miss out on the first few questions. Okay, so if you don't want to miss out anything, can you guys join us? The game pin is 5089472. Okay, we are going to go through a past year O-level paper. We are going to go through the 2020 paper 1, the first 8 questions. Okay, hi Panda Pao, how are you? Okay, so let's begin. Are you guys ready? Okay, let's go. First question. Okay, first question, you guys need to stand by your calculator. Okay, yep. So can you guys type this into your calculator and then give your answer to 3 significant figures? Okay, type this on the calculator and give your answers to 3 significant figures. Okay, you only have 25 seconds left. Okay, those of you who haven't keyed in, you have 9 seconds left. Okay, just punch into your calculator and give your answers to 3SF. It's as easy as that. Very simple, very straightforward. This is an O-level past year paper, by the way. Okay, now most of you got this right. The answer is actually negative 1.46. Let me explain. Yeah, so this one here, basically, guys, you just have to punch into the calculator and whatever value that you get from your calculator, right? Okay, so I'm just going to show you. Okay, for question 1 there, you basically just have to press your calculator. Let me grab my calculator. Okay, so you have, let's just punch into your calculator. You have a fraction there. Now, we have negative of negative 11, which is the same as positive 11, right? Then minus, okay, square root of negative 11 squared, okay, minus 4 times 16, okay, times a negative 50. Okay, did I press everything correctly? Do a quick check. 11 minus negative 11 square minus 4 times 16 times negative 50. Now, in the denominator, we have 2 times 16. Okay, and as you can see what I have on my calculator, right? Not sure whether you can see it. Maybe I bring it down. Oh, you guys cannot see what I press on the screen. Okay, so can you all see the number on the screen there? It's actually negative 1.45. Maybe I bring it a bit lower. There's a lot of things blocking the screen there. So when you see the screen there, it's negative 1.457128. We round off to 3SF, right? 3SF would be negative 1.46. Okay, you will round up because after 5, the digit is a 7, right? So that's why we'll be rounding up. Can? Okay, so that's why the answer is as such, like as just now. Okay, so you just have to key in your calculator correctly and you get the answers. Can? Sorry, the game code. Let me bring you to the game code, guys. Okay, now let me just bring this up. Okay, the game code is 508. Okay, sorry, my head is blocking. I need to stoop a little bit lower. Okay, so 5089472. That's the game code for today's game. Can? Okay, today is not Dubai Chocolate. Today we are playing for a $10 popular voucher. Can? Yeah, most likely if you didn't get it wrong, you were a bit careless in how you type your calculator. That's right. Okay, now let's look at the leaderboard, guys. Let's see who's the ones leading the game. Alright, so we have Rapid Sphinx as first position, Smooth Goose as second, and a few others at the bottom. Okay, but just one game, guys. We still have another 11 more parts to do. Alright, so yeah, we have quite a number we have quite a number of questions to do after this. Okay, let's move on to the next one. Let's take a look at the second question. Okay, you guys ready for the second question? Okay, in 3, 2, 1. Okay, by the way, we're actually going through the 2020 E-Math paper 1. All these are real past year papers from the 2020 E-Math paper 1. Okay, now it says here that y is inversely proportional to x squared. Which of these diagrams represent the graph of y against x? Okay, now, yeah, so is it diagram 1, 2, 3 or 4? The key word here is that they are inversely proportional. Okay, you have about 10 seconds left, guys. Okay, the correct answer is the yellow one. So just now you have some of you typing blue. Okay, not sure whether the person is really trying to deceive everyone or he's really honestly wrong. Okay, let me explain to you how this is done, guys. Okay, for the second question, right? Okay, we are given the fact that y is inversely proportional to x squared. Now, when it's inversely proportional, okay, what we know is that this is y equals to k over x squared. Okay, because it's inversely proportional, right, guys? Okay, the first thing we do is we have to rewrite we can actually form the equation connecting y and x squared as y equals to k over x squared. If it's directly proportional, okay, maybe let's use another color. For directly proportional, if let's say they tell you, right, if it's directly proportional, then this is the case where you have y equals to k times x squared. So directly proportional is k times x squared, inversely proportional is y equals to k over x squared. Okay, so if you look at the graph, right, okay, remember how your y equals to 1 over x squared graph looks like? Okay, I think you guys who are familiar with 1 over x squared, the graph looks like this. So the k over x squared graph also looks like this. Okay, so that's why the answer should be 3. Can? Okay, so I repeat myself again. When you have y is inversely proportional to x squared, it means that we start off by writing the equation y equals to k over x squared. Okay, and as you can see from the diagram there, okay, to get the graph of y equals to k over x squared, it's similar to the graph of y equals to 1 over x squared. Okay, this one is something that you guys have learned in Sec 3, right? Okay, the y equals to 1 over x squared graph looks like that, diagram 3. So y equals to k over x squared with a constant in front, with a constant at the top, would also look very similar. Okay, so the answer is diagram 3. Okay? Okay, let's go back to the question here. Okay, the game pin, by the way, is 5089472. Those of us who just joined us and you want to join the game pin is 5089472. Can? Okay, are you guys ready for the next question? Okay, thank you guys for sharing the live. Thank you so much. Okay, the game pin is 5089472. Okay, let's move on to the second question. To the third question. Okay, any changes to the leaderboard? Wow, first two still remains as the top two, but in the next three we have a bit of changes there. Let's see how this is going to evolve as we play through the game. Okay, let's move on to the next question. Okay, question 3, guys, ready for it? In 3, 2, 1. Okay, this one you have double points because this is a 2 marks question. Okay, it's a 2 marks question, so that's why I'm awarding 2 points. Okay, so in the diagram there, right, guys? Okay, so if you can see, maybe I bring it down a little bit. Okay, yeah, you basically have a circle, okay, and then there are 2 pairs of parallel lines there. BC and AO are parallel, okay, and the 66 degrees is given. Okay, try to see how you can make use of your circle properties to help you here. Okay, remember that there's a tangent there. AB is tangent. So think of your tangent properties. That should help you with this question. This one here involves circle properties and your angle properties. Yeah. So 2 things to make use of: your circle properties, because you have a tangent there. Make use of your tangent property. Then use your angle properties, because you got your parallel line properties there. 360. I'm not really sure which one you're referring to. Which 360 are you talking about now? At which point? Yeah, I don't think you need 360. wow, most of you able to get this right. Okay, some of you were complaining that it's difficult, right? But we got quite a number of you getting this right. That's nice. Okay, so let's take a look at how this is done, guys. Okay, to do this, right? Okay, for this question here, for part question 3. Okay, now what we know is that these two lines are parallel, right? Therefore, using the alternate angle property, I can say that this angle is also 66 degrees. Okay, why? Because of our alternate angle property, we have this line here parallel with the OA, right? So using the Z or your N, depending on how you look at it, these two angles are the same based on the alternate angle property. Okay, now once you've established that is 66, then we know, right, given the fact that AB is your tangent and OB is your radius, then we know that tangent and radius must be perpendicular. So you have a 90 degree there. So this is 90 degrees, this is 66 degrees, and inside the triangle OBA, you can actually find this. We know the sum is 180 degrees, so that allows you to find this angle here. Okay, which will be 180 minus 66 minus 90, it's just 24 degrees. Okay, so not that difficult. Okay? Okay, so let's go back to the question here. Okay, fourth question. Yeah, so 180 minus 90 minus 66, yeah, you're right, good. Okay, not difficult, right? Okay, nice. Let's move on to the next question, guys. Okay, question number 4. Ready? In 3, 2, 1. Oh, sorry, wait. Okay, leaderboard first. Forgot about the leaderboard. Okay, so Rapid Sphinx, okay, is still at first place. Not much changes this time, but let's take a look. There's still a lot more questions to go for. Let's see whether things change or not. That was a Sec 3 question. Yeah. Okay, this is a Sec 4 question. This is on statistics. Okay, so it shows you the graph of the rapid fall in newspaper circulation. Now the question is asking you about one misleading feature of the graph. Okay, so which one do you think is the correct answer, guys? They're asking for, okay, yeah, it's actually because of the fact that the graph doesn't start from, the vertical axis doesn't start from 0. So the green one is the correct answer. Let me explain to you why. Okay. Now, as you can see here, right, now this is something that I think even when you read newspaper reports, right, or sometimes when politicians or people in authority try to show you a certain statistics and they want to convince you in a certain way, they will do these kind of things. Okay, one of the way that they actually do is to actually notice that on the y-axis, on the vertical axis, they didn't actually start from 0. Okay, it starts from 1.2. Okay, now I don't want to say much because that would lead to the answer for part B. We've only done part A, right? So the misleading feature is that the y-axis doesn't start from 0. Okay, but how does that lead to the part B, right? I don't want to say much first. Let's move on to the second question before I actually explain to you how this affects the graph. Okay? Ken, so let's go back to the question. Okay, we have quite a lot more. This is only 4A, right? There's until question 8 and there are several parts. So yeah. I think this is, yeah, we still have quite a lot more. I think maybe another 8 questions. Yeah. Okay, so after these questions here, we have Rapid Sphinx again. Well, how come it doesn't change? You all must start to do something to challenge Rapid Sphinx. Who's Rapid Sphinx, by the way? Thanks for the follow, Boba Fett. Okay, who's Rapid Sphinx, by the way? You want to declare yourself? Or is it too early? I don't think it's one of us. I don't think Rapid Sphinx is one of us. Yeah. Oh, it's you, Arid. Okay. Let's see whether you're able to maintain. Okay, moving on to the next question, guys. Okay, question 4, part B. So the same question as we were looking at just now. Okay, so the answer just now was because the vertical axis doesn't start from 0, right? Now, the part B, they want you to explain how this feature affects the interpretation of the graph. Okay, what do you all think? Okay, Yeah, the answer is actually the blue one. Wow, most of you able to get this right. That's good, that's good. Okay, let's see why is it like that. So basically, right, if we were to go back to the question just now, okay, now the fact that you don't start from 0, right, you are actually zooming in. You're actually zooming into the portion from 1.2 to 1.6, which makes the difference, right, exaggerated, right? Because imagine, actually the decrease isn't that much. From 1 point something million, okay, from 1 point slightly above 1.5 million, right, to slightly above 1.2 million, it's not a big difference. But the fact that we don't start from 0 means that you are zooming in into the difference, and that makes the difference exaggerated. So that's why this is actually the thing that caused the misinterpretation lah, okay, on the reader's side. Okay, it's like, yeah, so basically the idea here is that the difference is exaggerated. It's because of like you are zooming in into the portion from 1.6 to 1.2. Okay, so that's the reason for part B. Yeah, the difference isn't that big actually. Okay, can? Okay, let's move on to question 5. Are you guys ready for the next one? Okay, let's look at the leaderboard. I'll see whether got any changes or not. Finally there's some changes. Okay, yeah, maybe cannot declare who's the leading one, otherwise you might jinx it, right? Okay, so yeah, Wonder Yeti is now first, Rapid Sphinx is second. Let's see how things change as the game evolve. Who's Wonder Yeti? Anyone wants to declare? Or now you're scared to declare already? Because just now somebody declared his first and then the scoreboard changed. Okay, let's take a look at the next one, guys. Okay, ready? In 3, 2, 1. Next question, question 7. I think this one is quite easy, right? Okay, write. Okay, sorry, let me just hold down a little bit. Okay, write 5a. Write 4 to the power 5 as a power of 2. Okay, write 4 power 5 as a power of 2. Okay, which is the correct answer? I think this one is quite straightforward. Yeah, I think it's a Sec 3 topic on indices. Detergent, yeah. You got disconnected. Oh dear. What happened? Is your Wi-Fi are you like outside? You're not at home? How come? Okay, I think we lost quite disconnected many times. I'm not sure why. I cannot help you on my side. I'm not so sure why is there an issue with the disconnection. Okay. Yeah, I really cannot help you with that. Yeah. Can I reload the question? If I reload, then I'm afraid the whole thing might disappear, right? Okay, let's just carry on from here. Okay, now let's take a look at the leaderboard. Any changes? Okay, I think because some of them got disconnected, right? So yeah, we have those are the leader scoreboards here. Let me explain to you how this was done. Okay, now for this question here, 4 power 5 to change it out of to a base of 2, right? What we do is we are going to, okay, so start off by writing 4 power 5. Now we know that this 4 here can be converted to 2 to the power of something, right? I think you all know that 4 can be converted to 2 to the power of 2. So applying your laws of indices here, we know that if we have 2 to the power of 2 and then raised to the power of 5, we simply just multiply the powers. So we have 2 times 5, that gives us a 10. Okay, can? Okay, so that's how we get 2 power 10. We multiply the powers. Okay, those of you asking for the code, thank you so much for sharing the code, guys. Okay, you guys are all very helpful, help one another. Okay, good. The code here, if you are still wondering, is 5089472. Okay, 5089472. Okay, can? 5089472. Next one is also going to be indices. Indices is actually under algebra. Oh, was that the reason? Okay, maybe I'll just go through with you the game first, and then after that, then we'll go through the answers. How about that? Are you guys okay? If I go through the game first, and then after that, then we will go back to the solutions. Would that be better? Okay, so let's finish up the game first. Okay, question number 5B. Okay, now this is another indices question whereby you're supposed to simplify the fractions there. You have one fraction divide by another fraction, right? So you've got to keep, change and flip. This is something that you guys learned since primary school, right? So what you do is keep the first fraction, change. Wow, that was fast. Okay, most of you are able to get this right. Wow. Okay, so I'll explain to you the answers in a while, guys. So you can just copy down the game pin first. Later on, I'll share with you the answers together because your friends are claiming that, you know, when I go to the other side, then the connection is affected. Okay, Ken? So let's finish the game first and then we'll go through the answers together. Okay, Ken? Alright, now let's move on to the next question. Or let's look at the leaderboard first. Any changes there? Okay, no changes. Wonder Yeti is still first. Okay, now this one is double points, guys. Okay, try this one, try it well because this is a 2 marks question. So that's why there are actually double points. Okay, can you guys give this a try? My math teacher keep on going to Times Square. What do you mean by Times Square? Okay, now you are given a hexagon, guys, a 6-sided polygon, and also an equilateral triangle. Now we're given the ratio of the perimeters. The hexagon is 1 unit, whereas the triangle has a perimeter of 2 units. So if you compare in terms of perimeter, right, the hexagon is 1 unit and triangle is 2 units. Now this question here, you might need a bit of time. You're asked to find the ratio of the areas of the hexagon is to the triangle. Okay, so you're given the ratio of the perimeters. We want to now find the ratio of the areas. Okay, yeah, a simple trick would actually be to find out the length of one side of your hexagon and one side of your equilateral triangle. Yeah, this one here a bit challenging. Okay, I'll be showing you the answers later, but you'll give it a try first lah. Okay, you have 40 seconds for those of you who haven't keyed in your answers. Okay, hi guys, those of you who just joined us, we're actually covering the 2020 E-Math Paper 1 and we are just going through the first 8 questions now. We're now at question 6. Okay, so there are a few more questions after this. I think 7A, 7B and 8A, 8B. So 4 more questions after this. Okay? Okay, so the correct answer is 3:8. I'll explain to you why, how we got to this answer. Okay, this one is the most challenging question if I were to look at the first 8 questions, right? This is the most challenging one. We'll see how this is done in a while. Okay, but we'll finish up the game first because what happens is that if I were to keep alternating between the solutions and the game, right, some of you got disconnected. So to avoid that, okay, we'll just finish up the game first. Okay, the scoreboard, we have Wonder Yeti at first place. Okay, let's see what happens. So question 7A. Okay, let's move on to the next question, guys. Question 7A. Okay, this is a Sec 4 statistics question. Okay, yeah, some of you might have also learned this in Sec 2. Alright, it depends on your school. Yeah, okay, but we're asked to find the median of these times here. Yeah, some of you learn in Sec 2, right? This finding the median in a stem and leaf diagram. Okay. Everyone disconnected. Oh no. Yeah, we don't have any answers. Oh, I think everyone, oh dear, what happened? It has ended. No one is answering. Yeah. Can you guys go and enter the game pin one more time? Okay, can you guys enter the game pin one more time? Then I'll, for the last few questions, I'll just, it says ended. Oh dear. How? Because I really cannot help you. I also have no reason, because I think towards the end I didn't start to change, right? Okay, maybe I'll just go through there. I'll take Panda Paul's advice. Let's just look at the questions, guys. Okay, so let's just, I'm so sorry about the Kahoot. Really, it's beyond my control. It's beyond our control, and it's something that we cannot anticipate also. Okay, maybe let's yeah, it's a Kahoot problem. I'm so sorry, guys. Okay, but never mind, we still can learn. Okay, so let's look at the questions that we were going through just now. Okay, I stopped at 5A, right? Let's look at 5B. Okay, now in 5B, right, we actually come across this fraction divide by another fraction. Okay, so what we'll do here is we will actually just change the divide to a times. Okay, I'm so sorry, guys. This is something that is beyond my control. Yeah, I really cannot do anything. Okay, now, yeah, so as we were saying just now, right, this is a divide and then you have a fraction, right? So what I'm going to do is I'm going to change the divide sign to become a times. Okay, and then after that, I'm going to flip the fraction. So from having 10AB over 21, I'm going to take the reciprocal. I'm going to flip it. Okay, 21 at the top and then 10AB at the bottom. Okay, now some of you like to do cancellations here. You can if you want. You can do some simple cancellations, but be careful, guys, when you do your cancellations. The thing about doing cancellations is that sometimes it gets very messy. Okay, so if you want to cancel off, do it very carefully. Okay, so I'm going to cancel off my a square with the a at the bottom here. Okay, so I'm cancelling off one pair of common factors a diagonally. Okay, what else can I cancel off, guys? Okay, any common factors that I can cancel off? Maybe you guys share with me in the chat. What else can I cancel off? 4 and 20. Oh, there's no 20. Oh, 4 and 10. Okay, 4 and 10. Yeah. Okay, so we can cancel off. There's a common factor of 2 there, right? So I cancel off the 4, I get 2. Okay, I divide the 10, I divide by 2, I get 5. Okay, anything else, guys? Oh, 3 and 21. Yes, good. Common factor of 3 there. So I get 1 here, I get 7 here. Okay. Now, I think that's all that I can cancel so far, right? Okay, so be careful when you do cancellations, it gets messy. So just have to be very careful there. Now, from this part, I have my 2, and then I multiply with my a, and then my 7. So 2 times a times 7, that's a 14. So I have 14 at the top, 14a at the numerator. And at the bottom, I have 1 times 5, right? So that gives me a 5. Okay, and then I have a b times b as well. That gives me a b square. So at the bottom, I'm going to get 5b square. Okay? Okay? Yeah, so you have b times b, so that makes it b square. Alright, so this is part B. You guys okay? Any questions that you want to ask? Oh yeah, I understand, detergent. Yeah. Okay, Ken, let's move on to, oh, Sharon, must teach us how to type in square. Detergent square. Okay, nice. Okay, now then we moved on to question 6, right, guys? So this is the one that's challenging. So let me explain to you how we got the answer for this one here. Okay, now what I did in this question, right, is to first understand that the ratio of the perimeters is 1:2. Okay, now if you were to think about it, right, if I were to because the perimeter is actually made up of all the sides, right? So if let's say I let this be x, then it's a regular hexagon, which means that all the sides are the same. So this must be x, 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 x. Okay, so in other words, right, the perimeter of the hexagon would be made up of 6x. Okay, thank you, Regina, for the follow. Thank you so much. Okay, now then we move on to the equilateral triangle. Okay, so let's label the sides as y. This would be y, y, and y, right, is an equilateral triangle, so all the three sides would also be the same. Okay, so what does this tell me? It tells me that because the ratio of the perimeters is 1:2, right, I know that 6x, okay, which is the sum of all the sides of my hexagon, okay, over my 3y, cos 3y is the sides of all my equilateral triangle, right? This would be equivalent to 1/2. Okay, basically I'm just rewriting the ratio from a ratio form into a fraction form. Hexagon 1 unit, triangle 2 units. So I'm just putting 6x hexagon, perimeter for hexagon, and 3y as my perimeter for my triangle. Everyone okay? Yeah, fraction. Yeah, I just turned ratio to fraction. Okay, now then what I can do here is this. I can cancel off the common factors. I'll get 2x here. Okay, cancel off with the 3, right? So what I can do is I can actually get rid of the fractions here. Okay, I can cross multiply actually. Okay, I multiply y with 1 and 2 with 2. So in other words, right, that 4x 2 times 2x is equals to y times 1. In other words, y is actually 4x. Okay, are you guys okay so far? So now that I know that y is 4x, right? Okay, how do I find the ratio of the area? Okay, now this is where I will need you guys to make use of what you guys have learned in Sec 3. Okay, yeah. Okay, I don't have space here. Where is a good space to do? Okay, so I know that my y is 4x, right? Okay, so to find the ratio of the area, the hexagon over the triangle, okay, I'll write it in the fraction format as well. Okay, I will probably write it here. Okay, maybe let me use another color. So this one, the purple one, would be the area ratio of the area. So area of hexagon, okay, over area of triangle. Okay, now the hexagon, right, guys, if you zoom in into the hexagon, right, okay, it is actually that there was a reason why they put the dotted lines there. The dotted lines, right, that comes from the center of the hexagon actually helps us to split up that hexagon into 6 triangles. 1, 2, 3, 4, 5, and 6. Now, if you look at these 6 slices, right, or these 6 triangles here, they are what kind of triangles, guys? If you look at each of these 6 triangles here, okay, what kind of triangles are they? How do you know it's equilateral? You're right, detergent. Okay, it's equilateral, but how do you guys know it's equilateral? Okay, because if you look at the center, right, we all know the angles at a point is 360. Okay, that angle at the center 360, if you divide by 6, you actually get 60 degrees. Now, each one of them is 60 degrees, and we know that all these sides are the same, right? So it must, what you have is an isosceles triangle. So if the top is 60, then these two bottoms must also be 60. The base angles must also be 60, and that's why we know that it's an equilateral triangle. Okay, so what we can do here is this. To find the area of the hexagon, right, we can actually take the area of one of the triangles there. Okay, I'm going to use my half AB sin C formula. Are you guys familiar with half AB sin C formula? Okay, if you have a triangle, right, this is a quick recap. Okay, sorry, this is not a triangle. Let me just erase this off. Okay, let's draw a triangle here. If I have a triangle there and I got my two sides A and B, and this angle is the angle for C, right? We can actually find the area by using this formula. Okay, if you are not in Sec 3 or you are currently in Sec 3 but you haven't learned Trigo, you might not seen this yet. Okay, but there's actually a formula. It's half times A times B times the sine of angle C. Okay, this is to help you find the area of the triangle there. Okay, so using this, right, I can actually use the right angle, I can actually use the equilateral, one of the equilateral triangles there. I'll just take half times AB, A times B, right, which is actually X times X, correct? Because the sides are made up of X, right? If you look at one triangle there, the sides are all X, okay? And then half times X times sine of 60 degrees. Now, sine of 60 degrees is not actually a nice number, but I'm going to leave it as that. Okay, because later I can cancel them off. Okay, now, so that's the area of the hexagon, the area of one triangle in the hexagon. Now, to find the area of the total hexagon, which is made up of 6 triangles, we got to multiply this by 6. Everyone okay? Hi guys, thank you for the follow, Nabila and Rain. Thank you so much. Okay, so we multiply by 6. Okay, now for the bottom, right? Yeah, you're right. Pendapau, you're right. If you have pentagons or other shapes, right, by actually cutting it into equal parts, you will not get equilateral triangles. This is something unique to hexagons. Yeah, regular hexagons. Okay, yeah, very good input, Pendapau. Okay, you're sharing things with us. Okay, good. Now, moving on to the area of the triangle there. Now, the area of the triangle also, because it's an equilateral triangle, right, wouldn't this also be 60 degrees? So, you will still be using the same formula, half times AB, which is y times sine of 60 degrees. Now, sine of 60, if you punch into your calculator, you'll get an ugly number, right? So, this ugly number here doesn't matter because you have a common factor of sine 60, which I can eventually cancel off. Okay, now this leaves, yeah, so the sine 60 I can cancel off, the half and the half I can also cancel off. Okay, and then I'm left with, in the numerator, I'll get x times 6, so 6x squared at the top, and at the bottom, I'll get y squared. Okay, now we have 6x squared at the top and y squared at the bottom. I'm going to actually make use of what we found here just now, guys, that y is equals to 4x, right? So I'm going to replace my y there with 4x. So 6x squared at the top, and at the bottom, I'm going to replace my y with 4x. Okay, don't forget to square the whole thing. Okay, and this is actually equivalent to 6x squared over the square of 4x, right, is actually 16, because you square your 4 and then you square your x as well. Okay, this allows you to cancel off the x squared with x squared. And that's how we get our answer, 3:8, or 3 over 8. Okay, and that's how we get to the answer of 3:8. Alright, so this one here isn't that straightforward. It's quite a lot of steps for 2 marks. Yeah, but yeah, it is a real O-level question that came out in 2020. Okay, thank you so much, Zarina, for sharing the live. Really appreciate it. Okay, Ken? Yeah, so this is the question 6 for the 2020 O-Level E-Math Paper 1. Ken? Similar triangles, wow, that is something to consider. You can actually use that approach, Pendapau. Yeah, actually using similar triangles will also work. Okay, yeah, but yeah, that was another avenue to actually explore. Wow, Pendapau is a very good student. Yeah, you can use similar triangles there because the triangles are equilateral, right? So they have the same shape. So similar triangles will also work here. We do teach actually, yeah. But I think this approach is less, yeah. I think both methods will be about the same. In terms of effort, will be about the same. Whether you use similar triangles or whether you use the method that I just shared with you guys. Okay. Okay, moving on to question 7. Okay, let's take a look at question 7, guys. Now, in question 7, this is actually a Sec 2 topic. Those of you who were doing this in Sec 2, you would know, right? Or maybe you are in Sec 3 or Sec 4, you have gone through Sec 2. Most of the time, this is like the last few topics of Sec 2 lah. Okay, so if you're in Sec 3, Sec 4 student, you might have remembered. Okay, and Sec 4 students, I think you will do a recap of this in Sec 4 again. Okay, now the question for the first part is asking for the median. Now, median is basically the data, right, that sits in the middle of the distribution. Okay, median is the data that sits in the middle of the distribution. Okay, so they are altogether 23 men. These are their timings, right? The fastest one is 75 and the longest one is 102 minutes. Okay, now to find the median, we need to find the middle position because we need to know which data sits in the middle of this distribution. Okay, to do that, okay, to find our middle position, right, let's do part A here. Okay, to find the middle position, okay, what we will do is we will take 23 men because that's the number of data points that you have, okay, plus 1 and then divide by 2. Okay, this is the standard formula. Okay, the formula, maybe I write it in red at the side. It's actually n plus 1 divide by 2. This is to find the middle position of a set of data. Okay, n plus 1 divided by 2. Okay, where n represents the total number of data that you have. In this case, we have 23 data points. Okay, now so 23 plus 1 divided by 2, right, is actually 12. Okay, we are looking at the 12th position. So you go and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now actually it doesn't matter where you count from. You can count from the bottom or you can count from the top. Okay, that means from 1, you can count backwards lah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did I count wrongly? Hold on. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, you still get the same number. Okay, yeah, you still get the same number regardless whether you count down or count upwards lah. Okay, you still get the same number, okay, which is 83. So that is the data that sits in the middle of the distribution, right? Okay, so we will leave the median is just 83 minutes. Okay, so that's how we get that 83. Thank you so much for liking the live, Ella. Thank you so much. Okay, so that's how we get the 83 there. Okay, now moving on to the next part. You guys okay with part A? Okay, for part B, right, we are told that there is another additional guy. So there's a 24th man. There's only 23, right? There's one extra guy who joined in, and the range increases to 33 minutes. Now, range, right, refers to, it's important to understand what range is. There are two range. One is interquartile range, and another one is just range. Okay, in this case, it's just range. Range is just the maximum minus the minimum. Okay, so let's calculate the range, right, before this 24th man entered the picture. Okay, so the minimum is 75, maximum is 102. So the original range, right, okay, is 102 minus 75. Okay, which is 27, right? Yeah, so that's your original range, guys. Now what happens was that, okay, this 24th person joined in the party, and suddenly the range changed to become 33. Now for that to happen, right, this person cannot be the number, right, his timing cannot be between 75 to 102. Okay, because if his timing is between 75 to 102, what happens is that the maximum and minimum wouldn't have any changes. Because if let's say his timing is 93, for example, right, his value will be positioned here. The maximum and minimum would still be 75 and 102, and therefore the range will not change. Okay, so what we got to do here, guys, is to understand that the fact that the range changed, right, means that this person might be bigger than 102. That means he's somewhere here, or his timing is lesser than 75. That's the only way the range could have changed. Okay, so assuming that his range is larger than 102, yes, sure, and we must plus how many, guys? Because if you look at from 33 minutes, right, when your range changed from 27, there is an increase of 6. So that's why from 102, right, you plus 6, and that's how we get, that's how Shu'en, right, got 108. Well done, Shu'en. So that's one of the answers there. Okay, good job, Shu'en. Okay, now that's assuming that his timing is larger than 102. Is it possible that his timing is smaller than 75? Yes. Okay, so you also now, for us to be smaller than 75 and for the range to be 33, I must minus 6 from 75. That's how I get the 69. Okay, so I take 7. So one is 102 plus 6. Okay, and then the other one would be 75 minus 6. Okay, that's how I get these two values here. Okay, are you guys okay? Yeah, so that's how we actually do this question here. Okay? Alright, let's move on to, if you have no questions, let's move on to the next one. The last question, question 8. Okay, I think part A is very simple, right? Okay, guys, maybe you guys can tell me what's the answer for part A. We have red counters, blue counters, and yellow counters in a bag. Probability, yes. Okay, now the probability of choosing a red counter is 0.45. Red has a probability of 0.45 and blue has a probability of 0.3. Okay, if red is 0.45 and blue is 0.3, what is the probability of choosing a yellow counter? Okay, I think the first part even our Sec 2 or Sec 3 students can do, right? Because this one is still lower Sec probability. Good, you guys give the answer 0.25. How do you get, question, how do you all get 0.25? P5 also can do. Okay, so to get 0.25, basically we know that the probability of the red and the probability of, so the red, right, plus the probability of blue, okay, plus the probability of yellow must all add up to one whole, right? Okay, so knowing that blue is 0.3, knowing that yellow is, yellow is the one that we want to find, okay, and red is 0.45. To find the yellow one, we just take 1 minus 0.45 minus 0.3. Thank you so much, detergent. That's how we do it. Okay, yeah, so this one is very straightforward. I think the lower Sec students are able to do this. Now, let's move on to part B, guys. Okay, this is where the challenge is. This is slightly more challenging because it's 2 marks. Okay, now we are told that in the back right, there's actually 9 more red counters than blue. Okay, now so what do we do here? We are asked to find the total number of counters in the back. Okay, now you can actually solve this using the algebraic approach. Okay, I can start off by letting x be the total number of counters. Okay, I can let x be the total number of counters. Okay, now which means, right, that to get 9 more red counters, I can actually find the number of red counters, which is actually just 0.45 times of x, right? This would give us 0.45 times of x would actually give us the number of red counters. Okay, and I would find the number of blue counters, which is 0.3 times of x. This would be the number of blue counters. Okay, because we know that out of the so many counters there, 0.45 of them, or 45%, or 45 over 100 of them are actually the red counters, whereas 0.3 or 30% of them are blue counters. Okay, and we know that the difference in the two counters, the red and the blue, are actually 9, so I can actually form my equation like this. Yeah, so I can find, okay, so I'm going to use Pendapau, find one whole, yeah, I think that's, yeah, you sound like are you a primary school student, Pendapau? Your approach seems very primary schoolish. Okay, yeah, but it's fine, it works, okay, it's a way, that's one way to do it, okay, but we can actually simplify the, no, it works, Pendapau, your method works, okay, but so what we normally do is in algebra, for secondary school, we'll just take the difference. 0.45 minus 0.3 is 0.15x, okay, and this is 0.15x equals to 9, right? Yeah, so to find x from 0.15x, to get 1x, okay, what do we have to do on both sides, guys? Okay, from 0.15x, I want to actually get to 1x. Okay, 0.15 to 1. You have to divide by 0.15, right, on the left, and I must also do the same on the right. Okay, and when you take 9 divided by 0.15, okay, if you have done this correctly, okay, you'll get 60. Yeah. Okay, so normally for secondary school math, we will the approach is slightly different. Okay, I think it's how we are wired. Okay, for secondary school math, we deal a lot with algebra, right? So we look at it like that. But for primary school, they look at it as the part and whole concept. Yeah, I'm not really an expert on primary school math. I think Pendapau looks like an expert here. Okay, Ken? So this tells us if x is 60, right? That would be the total number of counters that we have. Okay? Alright, so yeah, that marks the end of our 8 questions, guys, that we intended to go through. I really apologize for what happened with Kahoot. Probably in the next session, I wouldn't try to actually change or swap between screens lah. Okay, we'll just stick to Kahoot. I thought that if I could explain it like this, it would be better lah, because initially I also tried to share my answers on the Kahoot itself, but those answers are actually already done earlier. So you see the whole chunk of answers. Yeah, but I'm not sure. But if I were to do this, then so I'll probably discuss with my colleagues and see what's the best way to actually make sure that the Kahoot runs smoothly, and at the same time you guys are actually learning at the best potential. Okay? Yeah, thank you, Shen. Shen, we're actually ending the live already. Now then you want to share. But then thank you so much, Shen. I still appreciate it. Okay. Yeah, so if you don't have any questions, guys. Oh yeah, just now somebody was asking about signing up our trial sessions, right? Give me a moment now. Let me just bring you to that page. Okay, so we actually have this free trial program. Okay, really no obligation, guys. Okay, if you and just to share with you the programs that we have at MasterMaths. Okay, we have English at the PSLE level. Okay, for science we have from P3 to PSLE. Okay, for primary school maths P1 to primary 6 PSLE, and then we also have EMath and AMath at the secondary level. Okay, so from Sec 1 to Sec 4, both EMath and AMath, we actually do our regular classes. Okay, so if you're interested, if you're currently not a MasterMaths student and you would like to join us, do consider going for our trial program. It's free. Give it a try, and then if you don't like it, then you don't have to. There's no obligations. Okay, so it's really no obligation kind of trial thingy. Okay, so and I think if you bring a friend, there will be some vouchers. I'm really not so sure about that part, but yeah. All right. Yeah. Thank you so much, Pandepal, for your support. Okay, yeah, so if you're interested to join us, you can just capture the screenshot, capture the QR code, and then I think it will lead you to the page to register. Okay? Okay, so with that, I'll end off the live session, guys. Thank you so much for your support. Okay, and I'm ending the session here. Yeah, we'll meet again I think next week we will not be having a live session because of the I think it's the eve of a public holiday, right? The eve of Hari Raya, so I may not be having the live next week. We will probably be following up with the next one in 2 weeks time. So I'll see you guys 2 weeks from now. Okay, we'll try to see how we can find a way to make sure that the Kahoot runs smoothly and the answers are presented in a way that you guys maximize your learning lah. Okay? Yeah, I'll see you guys in 14 days. Okay, take care everyone. Have a good rest. Thank you so much, and happy holidays to you as well. Okay, yeah, so today is the last day of school, right? So yeah, enjoy your term, enjoy term 2, guys, and have a good one. Alright, all the best to your new academic school term. Okay, study hard and try your best. Okay, bye bye guys, take care.